All right, we'll get started. It's 10 o'clock. I want to thank everybody for taking the time to join Long's coffee break this Thursday morning. My name's Ryan Nedbalski. I am a sales engineer in Colorado Springs. Today we have Cambridge Air Solutions and Jacob Wyckoff will be joining us today. Jacob, thank you so much for joining us. And what do you have for us?
Yeah, thanks so much for having me, Ryan. So once again, I'm Jacob Wyckoff. I'm an applications engineer with Cambridge Air Solutions. Today, I'm going to be speaking with you guys about our S-Series direct-fired heaters. Those are our HTHV units, which stands for high temperature heating and ventilation. So I'm going to be talking to you a little bit about what that is, why it's so great for your high bay open spaces, and then a little bit about specifically applying our S-Series heaters. So jumping into it, what is HTHV? Once again, HTHV stands for high temperature heating and ventilation units. And that's not just a definition that Cambridge made up. That's actually a performance-based definition created by the Department of Energy. Those requirements are that it must be a 100% outside air direct fired heater with greater than 140 degree temperature rise, greater than 150 degree discharge temperature, and it must have fully modulating temperature controls to be able to meet both ventilation and space heating requirements. So HTHV is not new to the industry at all. Cambridge Air Solutions introduced the S-line in the mid-1990s, so it's a very proven technology. What was so special about it then, and is still so special about it today, is the 160-degree discharge temperature that it's able to achieve. And what that did was that really transformed your heat-only, non-ducted market. Your high bay, large open spaces like warehousing, distribution, and manufacturing. And it really did that because it provided three key advantages over the competing technologies that were available in the market then, mainly unit heaters. And it still provides these three key advantages over the competing technologies available today. So reason number one is the greatly reduced install cost. So because the S-Series heaters have such a large heating capacity in a single package, you're able to displace a large amount of alternative technologies. For example, one S-Series heater could displace 8+ unit heaters in a single package, which is going to reduce the amount of electrical connections, the amount of gas piping. Because it's direct fired, you no longer need to vent flue gas. All of these will compound into an overall lower install cost. Secondly, is the greatly reduced energy usage that they were seeing when installing these in retrofit applications. So anywhere from 40 to 60% reduction in utility usage, which result in great savings for these building owners. And really that comes from two key reasons. Number one, the improved direct fired efficiency compared to indirect technologies. And then number two is the elimination of stratification in these spaces, many of which were greatly suffering from it due to the high velocity discharge of our units. We'll dive into both of those in this presentation. And then finally, the free ventilation that these units are able to provide because they're using 100% outside air to heat the space. So because a lot of these buildings are relying on things like natural infiltration or leaky buildings to be able to provide ventilation, at times, a lot of them are sorely lacking in ventilation, resulting in poor indoor air quality for their occupants. And the S-Series heaters were really able to improve the indoor air quality in a lot of these spaces because they were using 100% outside air. So 100% outside air direct fired equipment is very commonplace in the industry. If you're not already familiar with HTHV, you're probably at least familiar with this top example, a makeup air style unit with the blower and a draw through configuration. Now, this is great if your main goal is providing large amounts of makeup air, like for an application that has a lot of process exhaust. We actually offer an M-Series makeup air unit ourselves with Cambridge, but it becomes less ideal whenever your main goal is primarily to heat the space rather than provide large amounts of makeup air. Because having the blower in the hot air stream, your belts, your bearings, your motors can't handle extreme temperatures, it's going to limit your discharge temperature to around 120 to 140 degrees. What Cambridge does differently for our HTHV units is we move that blower upstream of the burner into a blow-through configuration, which allows us to increase our discharge temperature up to 160 degrees. Now, this makes a huge difference whenever you're talking about heating efficiently using 100% outside air, which I'll show in a few slides. So how can it be efficient to use outside air to heat? You know, as kids, we were always told by our parents, shut the door behind you, you're letting all the cold or hot air out. We know from other applications how expensive it can be to process large amounts of outside air. So how do we square that with HTHV being the most efficient way to heat these high bay spaces? So it's important to remember that every building is going to require outside air for human occupancy. We know that from ASHRAE 62.1 building codes. And every building is going to have to get that air from either mechanical ventilation or from natural infiltration, one of two ways. So a lot of building codes these days are really catching up and realizing that you need some amount of mechanical ventilation. But for places that don't have the building codes caught up yet, there's still some advantages to providing that ventilation mechanically rather than through natural infiltration. You're able to filter the air. It's much more consistent than natural infiltration, which can fluctuate at times. And just for simplicity, whenever we're talking about heating using 100% outside air, it simplifies the conversation to separate the air load, which is the load that comes from your ventilation load, from the conduction losses, which are your heat losses through the walls and roof, the skin of the building. Your air load is going to make up about 30 to 70%, with the balance of that being the conduction losses. So what's the best way to heat the air load? Primarily, these buildings are going to be heated by natural gas or propane. In the marketplace today, there's two main technologies, indirect fired and direct fired. Direct fired is going to have the efficiency advantage at about 92% thermal efficient, whereas most indirect fired technology is going to be down around 81%-ish. That comes because the direct fired equipment is 100% combustion efficient, meaning there's no flue losses. You're not losing any of that heat through the flue, whereas your indirect fired technology, you would be losing some of that heat through the flue. The downside, some may say, is that your direct fired equipment must be 100% outside air. But whenever you're only discussing the air load, this isn't relevant to the conversation. So here's an example of the most energy efficient and the most competitive first cost way to ventilate a building. You'll see these a lot on things like commercial kitchens where they just need to provide neutral air, and then the ovens and other sensible heat gains in the space will cover the conduction losses. But in this example, we have 10,000 CFM coming in at 0 degree inlet air, discharging at 70 degrees. That requires a heating output of 869 MBH. Remember this example because we'll jump back into this in a couple slides. But what about the conduction load? So one way you could do it is you can add an indirect fired system at the efficiencies we discussed previously, with the benefit being that you could theoretically recirculate your indoor air through this indirect fired system. But another way to do it, and what we would consider the better way, is to simply turn up the discharge of the 100% outside air direct fired system that you already have to heat the air load of the building. You're going to get your direct fired efficiencies, and every degree you raise your discharge temperature above the space temperature, you're going to get heat BTUs that are usable to cover those conduction losses. We call those BTUs usable BTUs or net BTUs because they're able to be used to cover conduction losses rather than just the air load. So taking that same example we had previously, discharging at 70 degrees, by simply raising that discharge temperature from 70 degrees to 160 degrees, that's going to give us a delta of 90 degrees above our space temperature from our discharge temperature, which is going to provide 1,100 MBH of usable BTUs. Those 1,100 MBH of usable BTUs are all going to be usable to cover those conduction losses. Now, this chart right here does a great job of showing the importance of high discharge temperature when you're heating using outside air. So using our same example we had previously of an 1,100 MBH conduction load, we know that if we allow our unit to discharge at 160 degrees, it's only going to require 10,000 CFM of outside air to be able to cover that conduction load. If you were to restrict your discharge temperature down to 120 degrees, now it's going to take 24,000 CFM of outside air to be able to cover that conduction load. And then if you supplied neutral air, you'd never be able to cover the conduction load. But I think most of you in this call can see where this is going. So it's going to result in larger equipment that's more expensive to install if you're providing much more CFM than necessary. And you're also going to be wasting energy. So firstly, in fan horsepower from moving large amounts of air. And secondly, and more importantly, from processing large amounts of outside air. That's most likely well above any kind of ASHRAE 62.1 minimum ventilation requirements you might have. So I hope this really explains the importance of high discharge temperature when you're heating using 100% outside air. The next question we get often is, how do we avoid stratification? So we know that these high bay spaces are especially susceptible to stratification. They have tall ceilings. Typically, we're getting infiltration down through the floor of the building, like through open dock doors. We're typically mounting our heating equipment up near the ceiling, so it's out of the way, and so you have more floor space available, which results in a cold occupied zone for the people and the goods down near the floor, and a very hot ceiling line, which is going to result in a lot of heat being lost to the roof of the building. So how do we avoid that? So many alternative technologies are going to require some kind of auxiliary destratification equipment being installed with them, like HVLS fans, pair fans, or zoo fans. What HTHV does differently is we have a high velocity discharge on our unit, which is going to discharge the air anywhere from 1,500 to 2,000 feet per minute. And we'll discharge that air at a 45-degree angle from our unit. Very important to mount these units and discharge the air at specific heights so the angle matches correctly. But what that's going to do is that's going to sweep and induce the air across the floor, and then sweep back and induce that stratified ceiling heat at a 10-to-1 induction ratio. So meaning for every CFM of air that our supply fan processes, we're going to be moving 10 CFM of air that's already in the building due to that high temperature difference and due to the high velocity of the air. What that's going to do, if the units are laid out correctly, is that's going to result in a very low temperature difference, anywhere from 2 to 3 degrees from the floor to the ceiling and from wall to wall, and which is going to result in a large amount of occupant comfort and a lot more energy efficiency as you're not suffering from stratification in the building. And using 100% outside air is going to give the building a slight positive pressurization, which is going to reduce the infiltration that you would see through your open dock doors or other openings. So from a design consideration standpoint, something Cambridge has been doing for decades is we will run heat loads, provide equipment selections, and assist with laying out the units. And those are guaranteed by Cambridge. We've been doing those for decades, so we're very experienced. If the right information is provided and we're not meeting your set point, we'll do what's right to provide the labor and materials to get your building up to the set point that you designed for. So reach out to your local long representative if you want some help in that process. But just so we're all aware of the standard design principles we have, typically we're locating these near the greatest air load, like open dock doors. We typically like free airflow to the floor, and we'll take into consideration things like racking or other obstructions, just to make sure we're able to evenly mix that air throughout the building. HTHV is extremely flexible from a design perspective due to the relatively small pieces of equipment. What you'll see most often is these top two examples, the through wall and rooftop installations. We also offer under roof, indoor vertical, and outdoor vertical for your trickier applications. 10 models down from 250 MBH all the way up to 3.2 million BTUs. The smallest unit being around 200 pounds and the largest unit being about 2,000 pounds, which is really only the size of your standard dining room table, so still pretty easy to work with. Important to note that Cambridge will provide your inlet accessories like your rain hoods and inlet ducts, inlet plenums, things like that. And then also your discharge accessories like your discharge ductwork, and very importantly, those discharge directional elbows, which will ensure that you have your high velocity and that you're able to direct the air around the space like you're wishing. So thanks again, Ryan, for having me out here to speak with you guys about our S-Series heaters. If you want to think about using these on your next high bay space or any other variety of applications, please reach out to your local long representative and they'll be able to walk you through that process. Thanks again, Ryan.
Awesome. Thank you, Jacob. I really do appreciate you being here today. If anybody on the call wants more information, reach out to your local long representative and we'll get you in touch with Cambridge Air Solutions. Thank you for joining us and have a great day.